Here is an example of a couple of simple examples of the fundamental theorem of calculus part 1. This is an example that was supposed to be included in the first video, but somehow PowerPoint didn't include it. I'm sure it was not user error. Anyway, okay, so part 1 of the fundamental theorem of calculus. Find the derivative of the function g of x is equal to 1, the definite integral from 1 to x of the cube root of t cubed plus 1 dt. Remember that we are finding here, what we're being asked to find is the derivative of the function. So the derivative of the integral is the original function evaluated at the upper boundary, which is variable. So in this case, we find the derivative simply by substituting that upper boundary x in for our t. Remember, the derivative of the integral gives us the function, and we evaluate it at the upper boundary, which is x. Here's another one. Find the derivative of the function. Here we have a lower boundary of 17 and an upper boundary of x. That 17 does not matter in the least for this. We are only interested in the upper boundary, which is variable. It is the variable x. We are going to take the derivative of the integral, which gives us the function back, because the derivative and the integral are inverses of each other. So evaluated at the upper boundary x, we get that the derivative g prime of x is equal to quantity x squared minus 1 to the 20th. And finally, one more. We're going to find the derivative of the function h of x. Again, taking the derivative of the integral is going to give us that function back, but notice we have our variable boundary is the lower boundary, and according to the fundamental theorem of calculus part 1, that variable boundary needs to be the upper limit, not the lower limit. So we have the rule which allows us to swap the upper and lower limits, which gives us the negative of the original. So now we're taking the negative of the integral from 2 to x of this function. Remember, we're taking the derivative, which gives us, taking the derivative of the integral gives us the original function evaluated at x.